So, hi, my name is Katie Hogarth.
Hi, my name is Paula Pacheco.
And our project is on the green conversion of fructose to HMF using ionic liquids. So 5-hydroxy-2-foraldehyde, or HMF, is often found in honey and spirits. It's formed during heating processes or long-term storage and often shows food degradation. HMF has also been studied as an alternative to fossil raw materials. And currently, metal salts and acids are used to convert fructose to HMF. However, 1-allyl-3-methylmidazolinum chloride, or MnCl, serves as a potential green solvent. So for this project, we needed a synthesis, kinetic study, and quantitative study. So for our synthesis, we decided to make our own ionic liquids and characterize them through proton NMR. For our kinetic study, we wanted to find the most effective time for the conversion of fructose to HMF using UV-Vis. We originally used HPLC, however, we weren't able to get access to the machine quick enough in order to run our samples straight away for the kinetic study, so our results weren't good. So we decided to attempt using UV-Vis, and that is where we currently are in our project. For a quantitative study, we just want to determine the concentrations of HMF in whiskey Scotch samples and then determine how much using our calibration curve.
As for our methods, we have the methods listed here for the different synthesis we did. The one on the left is the synthesis for ionic liquids. We used 1-methylimidazole and we mixed it with allyl chloride. We synthesized MmCl, MmBr, and MmI, but this method remains the same for the three of them. We just use different allyls to make them. On the right, you can see the method for the formation of HMF from fructose. And what we did there was we mixed our ionic liquid with DMF to dissolve it. Then we added our fructose to it and we refluxed it for 45 minutes at 100 degrees Celsius. The results that we have so far are below that. On the top left one, you can see our proton NMR spectrum of the MmCl that we synthesized. All the different peaks are labeled there. You can see the peaks on the left correlate to the methylimidazole. And on the right, we use DMSO as our NMR solvent, and you can see those peaks there.
So we also decided to test the recyclability and reusability of our MmCl. And so this first bar graph right here on the right just shows the percent yields of both of them. You can see that they're very similar. It's about a 10% decrease in the recycled MmCl. However, that does show that they are recyclable and reusable. The next two spectrums are the IR spectra, and they are of the recycled and the original MmCl. You can see the similarities there, and that when recycled, it still is the correct solvent.
On the bottom left, you can see the calibration curve that we made for our HPLC studies. What we did was we took a standard of HMF and we dissolved it to different concentrations and got our calibration curve. And then on the right, you can see a bar graph comparing the yields of our MmCl, our MmBr, and our MmI. The MmCl and the MmBr showed similar yields, while the MmI probably only produced trace amounts that we couldn't detect in the machine. But it does show that the MmCl and the MmBr have similar enough yields that they're both viable, and since the MmCl is a cheaper material to make, that's the one that we've been focusing our studies on.
So for our conclusions, we determined that MmCl-DMF binary reaction media is an excellent combination for the conversion of fructose to HMF, and we believe that the efficient, cheaper, and reusable catalytic system has a great potential for application in the future. And we hope that this work can provide an effective and environmentally friendly way to convert fructose to HMF in comparison to metal salts and acids.
For future works, what we are currently working on is completing our kinetic study using UV-Vis instead of HPLC to measure our HMF concentration. And then we want to do our quantitative study to quantify how much HMF there is in our different whiskey Scotch samples. Thank you.
Thank you.